Hello folks, this is the video tutorial for homework 1, which is assigned to the people in Lab 54, meeting on Tuesdays 8:30 to 8:30 a.m. to 11:20 p.m. Oh, no, 8:30 a.m. to 11:20 a.m. Now, there are two problems in there, but I asked you only to submit the first one, okay? So the problem under consideration is shown below. It's a simple part made of steel, and the inside of this hole is clamped, and this face ABDC is subjected to a pressure of 50 psi. Now, notice that it says make sure that the mesh around the mesh around the hole is finer, so you have to do a local mesh refinement here, and make sure you take all the planes of symmetry which are applicable to this problem. Identifying planes of symmetry and taking it is a big chunk of your grade in the final on the midterm exam, and the only way to do these is doing problems through experience, watching the videos, going to the lecture, going to the lab, etc. And gradually it will grow on you. Okay. So if you look at this problem, use your common sense. This entire face is clamped, and you're pushing with a constant pressure on that face. Common sense tells you that if you take a cut with a wiser plane, in other words, you cut it uh, with something parallel to the wiser plane, halfway between these two faces, everything on the left and the right are the same. So there is a wiser plane of symmetry. Also, because of the nature of loading, xy, if you cut it with the xy plane, or something which is parallel to the xy plane, halfway between the top and the bottom, that's also a plane of symmetry. So it's up to you whether you want to model a quarter of that piece, or model this whole thing and then cut it with the appropriate planes to get the quarter model. Now, when you go to the second problem, which you're not supposed to submit, the pressure is applied on this face, on the side. When you think about it, the only plane of symmetry here is the xy plane. There is no other planes of symmetry, okay? Whereas in the other one, xy was a plane of symmetry and yz was a plane of symmetry. So first I'm going to do this problem, and then I'm going to come back and finish problem number 2 for practice only. Okay, so let's go ahead here. Start with the part file. Right now you're analyzing parts. In a few months, in a few weeks, when you be analyzing assemblies, then you have to start with the product file. So file, new, with a part. Uh, I'll just call it part, okay, instead of part 1. There we are. And right away, I'm going to save this thing. So you go to File, Save Management, Save As. On the desktop, on my desktop, I make a new folder, and the name of that folder, we'll call it Homework 1, Lab 54. Okay, so this part, which I'm going to give it a name, proper name. I don't want to call it part because if accidentally I make another thing with the same name, part, it's going to overwrite this. So I'm going to do it like this. Uh, Homework 1, problem 1, I'll give my name. Okay, and then this thing, I leave it at the end, or I can take it off, or could have been part 1, etc. What is identifying this is actually Homework 1, problem 1, and the name that I gave it. Okay, so say OK. If you check your desktop, you will see that it's right there. This is the folder that I created, Homework 1 Lab 54, and this is the part that I made. Okay, and I haven't made anything yet, but I will. Now, on this vertical plane, I will sketch on purpose, I'm going to do this thing a little bit harder than what it's supposed to. So I'm going to create that sketch over here. And the sketch that I'm going to create is basically this front view, okay? So uh, this is not how I would do it if I had to do the problem, but I want to show you a few features. That's why I do it. I'm going to do it like this. Draw a line like that, and this is going to be a construction line because I want to create the shape and then make it symmetric with respect to this. Okay, so let me draw that. Uh, I don't want this thing to be construction. Oops, this one is construction, right? Okay, good. Now I'm going to draw a cross section like this, but I don't want this thing to be construction anymore. So this is like so, there, and here we are. Okay, now I want to make sure that this is symmetric with respect to that line. So here's the way I'm going to do that. This line, control that line, control the middle axis, and you go to this icon which says constraint defined in the dialog box, and you want to make it symmetric. You see, now when I do this, it's going to stay symmetric with respect to it. The alternative would have been to give a dimension here and a dimension there, and these dimensions would have been the same, etc. But I like using this guy a lot. So let me draw the other circle here, and let's dimension these. So this one is 10 inches. Okay. This radius is 4, and this circle, the radius or diameter is 2, radius. Okay. All right. So now you can see if I move this. Now you can see that if I move this, it's going to stay symmetric with respect to that line. Very good. So exit, and I'm going to pad it 1 inch in each direction because the total thickness here is 2 inches. See that? This is 2 inches. So if I do the mirror extend, I have to type in 1 inch. Very good. Now on that face, I will sketch. I'm going to draw a rectangle. What I'm trying to do is this piece. See that? This piece. And this line, control that line. We're going to make it coincident. This line, control that line, coincident. And this line, control that line, also coincident. See, what happens, I can take this and move it, it won't go up and down because I made these coincident. Now, we know that this dimension is 1 inch. So let's do that. There we are. And now we're going to exit. And we're going to pad it. I believe that is 2 inches. There we are. Now I can do the same thing on the other side, but the alternative is to mirror this part with the sort of back plane. So let me do that, do it like this. So the mirroring element is this back plane, and the entire current solid is mirrored, and there we are. Oh, wait a minute, this, I don't know, what did I put here? This is too thick. I think that maybe this first pad should have been 1 inch. Mirror extend. Cancel for a second. Somehow I think this is thicker than. So this is two. Oh, these things should have been 2 inches. So let me see. This other pad. 2 inches. Oh, you know what? I made a bad mistake here. Let me delete this mirror. I know what I did wrong. Okay. So what I want is this mirror. The plane is still that back plane. Okay, very good. But I don't want the entire solid. I don't want the entire solid. I want this last pad that I made. See this? And then we say, okay. Ooh. Okay, so let me see for a second. Undo. Okay, so mirror, mirroring element is here. Cancel. Okay, the mistake was right there. Let's do it again. So mirror with respect to this plane, with respect to the YZ plane, and say okay. There we are. This is a lot better. Very good. Now you can create this in any other way. There are no unique ways of doing these problems. You may like your own way of doing it. That's fine. I understand that. Okay, so what I want to do now is I want to make a cut along this, okay, and a cut in the horizontal direction. So first of all, cutting is is this saw split. So we're going to use the YZ plane and keep the side that's closest to me right there. I also want to cut it with the horizontal plane, something parallel to horizontal plane. But the way I did it, this YZ is not itself cannot be used. Because I did a mirror extend, I could have used the YZ, but not with the XY. Okay, so what I need to do is to create a plane halfway between this height. So the first thing I'm going to do is create a point between this point and that point, okay, and exactly halfway. And then I'm going to create a plane, uh, which is the way to do it is I'm going to use it parallel through a point. So the reference is that XY plane, so parallel to this and through that point. So now I get a plane which is exactly halfway between the top and the bottom. And then we can use the split or the saw to cut it. So we're going to use this. Let me keep the top piece. There we are. The bottom line is that if you created this thing any other way, that's perfectly acceptable. Uh, but I'm going to do it like this because later on, when I do problem number 2, and I don't want these, or may not need some of these symmetry planes, I can suppress them. Okay, so save it. We're pretty much done. So now go to generative structure analysis, static analysis. Oh, I forgot to assign material properties. So let me get rid of this. Okay, apply material, metal. This is a metal tab, steel on the part. Say okay. All right, and now we're going to go to generative structure analysis. This time it's not complaining about material not defined. That's fine. Let me change the rendering here so you can see it better. Now, this is the element size, default element size, and it's using parabolic. Fine. But the problem says make sure that you have a finer mesh around the hole. So to do that, you go to Model Manager, second icon, second toolbar on the left, this guy, Local Mesh Size. So you can select the support where you want the finer mesh. See that how tiny it is right there? That's controlled by this number. So maybe if I want 0.2, I don't know. I want to make sure that you guys know how to do it. Right now, there are no instructions given as the value, okay? And then if you want to look at your mesh, right click, put the cursor on nodes and elements, right click mesh visualization, and there we are. You can see that it's finer here and coarser there. Okay, good. To do the rest of the problem, either you delete that or deactivate it. Okay, very good. So now what are we told? We are told that the surface is clamp. So there's the clamp icon on the restraint, clamp icon right there. Okay. And you are told that this face is subjected to a pressure of 50 psi. Okay, so if this face is 50 psi, because we're taking 1/4 of that, you take 1/4 of this 50 over 4, which is 12.5, and apply 12.5 psi to that face. Wrong. This is a pressure. It doesn't matter how I cut it. The pressure on the face, whether you take the whole thing, a little piece of it, etc., is still 50 psi. If this was 50 pounds and you made 2 cuts, 4 cuts like that, or 2 cuts like that, then on this face, it will be 1/4 of the 50 pounds, but not psi. 50 psi. People lose a lot of marks on this on the test. Be careful, okay? So pressure is right there on that face, 50 psi. There we are. Positive pressure means compressing, pressing into the face. Negative means it's tensile, pressing out of or pulling out of the face. I want it to press into the face. Now, this is very important. You go to file save management, file save management. Notice that my part was saved. I know that. I already did it, okay? But analysis that was just created is not saved, okay? So you have to do that, save as. We're going to put it in the same folder, homework 1, lab 54, but I'm going to give it a name that I can recognize and associate with problem 1. So it's going to be homework 1, problem 1, okay? Your name, my name, no, your name on the test. And then as far as analysis, this is analysis file. So it's up to you whether you want to make this analysis 1 or analysis, because the identifier is right here, problem 1. Okay, I'll take this out, the one out, so it doesn't confuse you. There we are. Let me say okay. Now if you go to your directory or your folder, right there, you see this is the part that you saved. This was the part that you saved. Okay, and this is the analysis that you just saved. I would have liked to call it, I don't know, it's like lab 54, but it doesn't matter. Okay, fine. This is done, so we can run it. Something that I forgot. Bad, bad, bad. No. When you make cuts, these surfaces that you create, you have to put surface slider on them because they're plane symmetry. Plane symmetry means that if I looked at it like this, a point in that plane will not go sideways to the left or to the right, it stays there. So that means the roller right there, and this bottom face and that bottom face. Don't put it on the circular face because that is not a symmetry plane. Okay, that's not a roller. You say okay, save it, and then run it. Just ignore this warning message. At least try to read it. Okay, so what's going to happen is that this is going to get compressed. There we are. That doesn't surprise you because this is not a this is a flimsy kind of a cantilever beam. Okay, so everything is moving. Everything is moving except that this is moving more because this is flimsy compared to that piece. If you want to look at displacement, average ISO, change the rendering. There we are. If you want to see the elements here also on top of the contour like this, you go to the rendering, the last one which has a question mark on it, automatically puts the elements for you. And it looks like good looking colors. The problem is that in finite elements, you can create very good-looking garbage, okay? So notice that I have no idea whether this mesh is sufficient or not. All I know is that here I have a finite mesh. That's a good sign, but you know, I have no confidence in the results. This course is primarily about teaching you the how to. The why part of it is extremely important, but we don't put too much emphasis on it because That's where you get to use these things in your other projects, capstone or some other design course, okay? Most of the stuff that I show you here is the process behind this uh, getting to some result. The accuracy of the result, you must spend some time on it and use your common sense also. Now, if you want to look at the von Mises stress, there we are. It doesn't surprise you because if you have a cantilever beam that's bending, the biggest stress is at the wall, at the clamp, basically. This is kind of the clamp compared to that piece. Okay, so if you have a at the root of the wall, let's put it like this. And over here, of course, you have gigantic stresses because you don't have any fillet. Okay, that's what I mean. This may not. It's a good-looking garbage, maybe good-looking garbage, but you really put fillets there. The fillet reduces the stresses, and the mesh must be fine enough, etc. None of those we're looking at here. Okay, so save it, save everything. Now I'm going to close this analysis file, and this is the part that I use. I'm going to save it as a different part. Problem 2. Okay, so file, save management, this guy, save as. I'm going to put in the same folder, but not call it problem 1. I'm going to call it problem 2. Okay, and okay. So any changes that I make here will not affect that problem 1 that I saved, both its part and of course the analysis is going to be different analysis, so it's not going to affect that. Now, a couple of things. The problem that we're doing here is like this. We are pushing problem 2, we are pushing in this direction, okay? And there's only one plane of symmetry, and that is cutting it at the bottom line. Okay, so let's see if we can do it like this. So this one we want to keep, but that guy we don't want to keep. Let's see if we can deactivate this. Okay, unfortunately, the way I did it, I made that first cut. Uh, then okay, so let me delete these. Start from the bottom. Delete this. We keep. Let's delete this. Rather unfortunate the way I made my model. I cannot deactivate these. So okay, and this one is also going to go. Okay, so I'm going to cut it with a plane in the horizontal direction. Remember how I did it? I created a point halfway between this point and that point, and a plane parallel to the XY going through that point, and then I'm going to split it right there, split with this, keep the top part, and there we are. So, I was not thinking when I was making the model because these models are simple enough. Even if I do a bad move, I can come and kind of recreate the model again. So, because of the way I did it, I could not deactivate those things. So, anyway, there we are. This is the problem that you have. Okay, save it. The name was already changed to problem 2. You can see that. And material is still there. So now we're going to go to generative structure analysis. Change the rendering so you can see it better. Okay. This is a surface slider. So let's go ahead and put surface slider on this face and that face. In the prior problem 1, I also had a cut like that. And that's why I had to put that thing on the surface slider. Yep. Okay, so now we're going to apply pressure. Well, how about clamping this face? Okay, and pressure on this face. Okay, and the value is don't divide this thing by 200 psi, 200 psi. So make that thing 200 psi. Okay, And then I said that you need you're supposed to make a finer mesh around the hole, so you can do that now. So you click on the local mesh size over there. Let's use the same size that we had before. Why don't we look at our mesh 2? So put the cursor on nodes and elements, mesh visualization. You can see it's finer here. Good. Deactivate your mesh. Make sure you save your analysis. So file, save management. This is the analysis. Save as. And before I had problem 1 analysis, right? So just make this thing problem 2 because I don't want to overwrite the previous one. I don't want to overwrite it. Just I want to give it a different name. One of the most common ways that people lose marks on midterms is that they overwrite their files and then they submit it, and it's not what they intended to do. Okay, so save everything and run it. Ignore this rotation constraints were not taken into account. Fine, I understand. I understand. Okay, so obviously this is going to bend like so, like that. You can animate it. Okay. If you want to look at your displacements, if you want to change the rendering here, average ISO, material shading, you can see that. You want to see your elements, you go all the way to the end, click on the question mark. That much of deflection. I have no confidence in these things because to have confidence, you have to do mesh convergence study, fillets, etc. And because most probably, I mean, if there are no fillets, it could be that these things yield. CATIA does not predict yielding and stuff like that for you. Garbage in, garbage out. Okay. Now, if you want to look at the one meso stress, guess where I expect to be large stresses? Right along these sharp edges. Look at the one meso stress. Now, in this particular problem, it, I would have expected to be there, but it came out to be in these spots. Okay, so now while I'm here, let me do the following. So let me deactivate this spot. I have a reason for doing that. Deactivate this. I'm going to make a box group here. So let me make a box group because the stress here was so large that it overwhelmed everything that was done there. So let me see now. Box groups. Oh, right there. Okay, box group. Make the box. I want to position it properly. So I want to take this box and put it there because I want to stay away from those that location. Let me resize it. This one's okay. Where's the other end? There we are. Okay, so let's also bring this thing, make this thing a little bit bigger. There. So, okay, if you want, I can also bring this thing down. So what I'm going to do is I'm going to look at the stress distribution only for elements inside of that box because I know that there is a red spot there. I don't care about that. So if you double click on one meso stress on the selection, show me the stuff in the box group. There we are, and hide this. So the fact that it was all blue before doesn't mean there was no stress in it, low stresses. It's just that that spot, red spot around the hole was so big that it overwhelmed the display of everything else. All right, folks, save everything. This was problem number 2. Now let's make sure everything is there. Get rid of this, get rid of CATIA, get rid of that. There is the homework that you did right there. And you did 2 problems. Problem 1, part analysis. Problem 2, part analysis. This problem 1 is still the old one. If I double click on it, Old one means two planes of symmetry. Yeah, this was the one with the two planes of symmetry. You can see that. If I go to the problem two, that's the one with one plane of symmetry. I can even put them side by side so that you can see it. I did not overwrite. Okay, so let me try this. This was problem two. Remember the one that I made a group for you? Okay, so can I tie it vertically? The other one is not showing up. Okay, anyway, it's all there. Good luck.